I'd like to show you a little bit of what I think the future is going to look like. I'm going to take you out to the edge, no pun intended. I know what you're all thinking, like, how can I actually say that cloud computing is coming to an end when it hasn't really started yet? Well, let me show you, and here's what I think you probably all think, that I'm crazy. If I had stood up here 20 years ago and told you that Microsoft Windows might go away in the future, or 30 years ago that Digital Equipment Corporation might be out of business, or 15 years ago that Sun Microsystems might not be here, you'd probably put the same slide up here and say, boy, that guy's, he's gone crazy. These companies or these technologies will be around forever. Everything that's popular in technology always gets replaced by something else. It always goes away, and that's either the beauty, the opportunity and beauty of the business is that these things actually go away. And part of our job as investors is to look at not where the puck is today, but where the puck is going at some point in the future, typically 5, maybe 10 years out. I mean, it takes a long time for companies to build up, and you want to hit that puck where it intends to be. And a lot of what I think about, it's actually a very simple exercise I would encourage you all to do if you ever want to predict the future. Subtract something that's important today and fill it with something else. Take an important thing, take it away, and go fill it with something, and you'll start to think out of the box as opposed to sequential. Like we could say, oh, there's more cloud computing, more of this. I believe that if you subtract something, you can actually fill it with other dimensions that you might not think about if you just sequentially go and order something in your mind. I did that with cloud computing. About 6 months ago, I started to think about, I call it my Forrest Gump rule of investing. It's like so simple, it's almost stupid, that you just subtract something and replace it with something else. And about 6 months ago, I started to think, well, what happens when cloud computing goes away? You know, of course, to myself, I'm like, well, it's so popular right now, how could it go away? I think it's actually happening right under our nose. And let me show you and let me explain why I think that's occurring. Today's world is a centralized world. And the processing that gets done when we when we have our mobile devices, the central cloud is where all processing, where data information gets done. When we do a Google search or whatever, you type something in on your phone, that little stream of information goes back to the cloud, it gets processed, the information then comes back to your phone. All of that's being done centrally, and to some degree, your mobile devices are a terminal or a display vehicle of what's happening in the cloud itself. So we're living right now in a very centralized model of the world. And when I thought about the end of cloud computing, I started to think, well, maybe our mobile devices get way more sophisticated, and I started to think about when we text one another. When I text anyone in this room, my text doesn't go directly to you. It goes to some data center in Norway and then comes back to here. Like that's the central hub and spoke. I text, it goes to the central cloud, and then it pushes it somewhere else. And I started to think, well, maybe it's mobile devices that become this next generation and obviate the need for the cloud. And intellectually, that became a cul-de-sac, and I started to think, well, it wasn't mobile devices, but it's all the other things that are going to be out at the edge that are going to truly transform cloud computing and put an end to what we know as the cloud. And so the change is that the edge is going to become a lot more sophisticated, not with mobile devices, but broadly speaking, with the Internet of Things. Examples are self-driving cars, drones. I know we hear a lot about this. Drones, robots, and all the Internet of Things objects that will be created over the next 10 years. You think about a self-driving car, it's effectively a data center on wheels. And a drone is a data center with wings, and a robot is a data center with arms and legs, and a boat is a floating data center, and blah, it goes on and on and on. And so these devices are collecting vast amounts of information, and that information needs to be processed in real time. That is, the latency of the network and the amount of information, many of these systems, there isn't the time for that information to go back to the central cloud to get processed in the same way that a Google search gets processed in the cloud right now. And this shift is going to obviate cloud computing as we know it. This is a circuit board that's inside of a car today. A luxury automobile, not a self-driving car right now, has about 100 CPUs in it today. So if you think about self-driving, a self-driving car in the not-too-distant future may have 100 of these cards, maybe 200 of these computers that are inside the card. So that becomes a data center. Hundreds of these connected computers in a car becomes a data center. And then think about connecting thousands of cars together. It becomes this massive distributed computing system at the edge of the network. And for those of you who are around, we are entering the next world of distributed computing, just like we saw in the past. It's kind of returned to, it's literally back to the future on where processing gets done because of these very, very sophisticated endpoint devices. So it's interesting to note, in addition to these devices getting sophisticated, it's really all about the data. And for the first time, if you think about these endpoint devices, for the first time in computing history, we're collecting real-world data about our environment, whether that's vision, location, acceleration, temperature, gravity, information. But visually, we're collecting the world around us through very sophisticated sensors. Up until now, computing has fundamentally been us humans typing things in via a keyboard, or a computer generating information from a database or generating log files or whatever. But this is the first time where we're starting to collect the world's information, and that data is massive. The other part is, so it's real-world information coupled with the idea that real-time data processing will need to occur at the edge where the information is being collected. I use the self-driving car as an example. If we had a way, let's say we're collecting real-world information on a self-driving car, so it's collecting images. And as part of an image, there's a stop sign. Well, if I had to, take that data, send it off to the cloud to decide that there was a stop sign or a human being crossing the road, that car would have blown through the stop sign, run over 10 people before the cloud came back and said, hey, you ought to stop. The notion of real time becomes a very important ingredient given the massive amounts of real-world information. We're not talking text information. It's real world, like collecting video and streams of information. So both of these things need to work together, and data absolutely is going to drive this change. Well, I mentioned distributed computing. We are now returning to back to the future. If you think about the trends in computing, we started with mainframes as the, sort of the beginning of the modern computer era. That was a centralized model. We then moved to a client-server model in the 80s and 90s, and that was a distributed model. Mobile cloud brought us back to a centralized model, and believe it or not, we are returning to an edge intelligence distributed computing model that's absolutely thematic with the trends in computing of moving from centralized back out to distributed. The other thing that happens, which is interesting in terms of the number of users that actually, or number of systems that are out there, is within each of these trends, we have a massive uptake in the users and devices that are out there. Mainframes, best case, there were, call it 10 million people that used mainframes with terminals, and there were 10,000 mainframes, 1,000 people per mainframe, call it 10 million people max on mainframes. When we moved to PCs, we had about 2 billion people use PCs, so we see these increasing orders. Now, what's also interesting is that if you think about the total addressable market, I've always thought a total addressable market for computing is the number of humans on the planet. After all, once every human has a mobile device, why do we need more computers? Well, the Internet of Things actually drives us to an entirely new dimension because computers are no longer attached to humans. And so I can envision where we have 5 billion, 7 billion mobile phones. Let's say everyone on the planet has a mobile phone. Let's call it 7 billion. I can imagine a world where there will be trillions of devices out there. So if you think about the challenges of management, security, data, all of the issues of distributed computing, that's now it's the opportunity and the challenge of what we're all going to face in the not too distant future. It's happening right now. It's starting with cars and drones, and it will proliferate to lots of other devices in the not too distant future. The other ingredient which I also find interesting at this point, is the intersection of machine learning and all of this endpoint data that we're collecting. I believe that machine learning actually catalyzes the edge adoption. There's massive amounts of real-world information that requires a machine learning approach to decipher the nuances of the real world. So the only way that we can look into an image or look into the massive amounts of data is with machine learning. And that machine learning, the algorithms and the applications employing machine learning will run at the endpoint. It's not going to be machine learning running in the cloud. So what does the cloud become in this case? The cloud becomes a place where learning occurs and a place where, I'll call it the last point of information storage. Important information will still get stored in a centralized cloud, but much of the processing in this new world will move out to the edge, and that's where the most important decisions will get made at the edge. This all matters because it turns out that humans are notoriously poor at making decisions. I have a Tesla, and I think that autopilot, which is like a very simple step towards this world of automation, is hugely beneficial. Like, it's one of the most awesome, it's a great innovation in terms of helping. My autopilot is a way better driver than I am, even with all its flaws. Like, I'm a terrible driver because I text and I yell at my kids and whatever, and so autopilot has none of those issues. It just goes down the road. It's awesome. We can see that through the right use of data, machine learning, these elements are going to be way better and way more helpful to us than we ourselves can be helpful on our own data. So let me take you inside the edge and talk about what's happening at the edge and then centrally in the cloud. At the edge, there's three things that are happening: sensing, inference, and action. There's actually a very interesting parallel here with fighter pilots. There's a framework for training pilots that was developed by Colonel John Boyd, who was a top dogfighter. And he invented this feedback loop. It's called the OODA loop. And OODA stands for observe, orient, decide, and act. And what the conclusion was with John Boyd was that if I could take a fighter pilot and create the fastest loop in his brain, his or her brain, to process the information around, this is in a dogfight, that you would win every battle against the enemy. Because the processing that occurs in my reaction to that loop, to the extent I could do it faster than anyone else, means that I win. And the idea of this OODA loop was that it prioritized agility over power. And as we think about this new edge computing paradigm, it really is agility over power. The endpoint device is nowhere near as powerful as the cloud itself, but we can be much more agile because that information loop is going ever so quickly at the edge, processing just the information that it needs. And what I think is that over time, the beauty of machine learning and what's going to happen is that loop, and I'll call it the sense, infer, and act loop, will go faster and faster as processing gets more powerful, as machine learning gets that much better. That loop will get ever more tight against new information coming in. There's a big parallel there between kind of this new world and how frameworks for fighter pilots have actually been developed. So that happens on the edge, agility out at the edge. And then the cloud does have a purpose. The cloud is going to be all about learning, and that happens centrally. So I'm going to take all of this information that I have out at the edge, I'm going to connect these devices, I'll curate that information, and learning will occur centrally, and then propagate that information back out to each endpoint device, creating an ever tighter, more agile loop that happens out at the edge. Okay, I'll talk about a couple of these things. The first is sense. Sensors will include cameras, depth sensors, radar, accelerometers, and will be everywhere generating massive amounts of information. As an example, a couple of interesting examples on the amount of data that's actually collected. A self-driving car generates about 10 gigabytes of data per mile. That's a lot of data. A Lytro camera, which is a data center in a camera, generates 300 gigabytes of data a second. Just massive amounts of information. And it's not just complex devices like a car or a camera. Sensors will be in just about everything. I put a picture of a running shoe here, because in the not too distant future, we're going to have sensors in running shoes. That sensor will collect information. Your running shoe will run a machine learning algorithm with a very fast loop in it. And when you're running, it's going to say, hey, you're going up a hill, you ought to shorten your stride, or you're not doing as well as yesterday, or you ought to pack it up for today and go home and get some rest, or whatever. But the shoe is actually going to be smart. So when I talk about these devices, it's not just complex big systems. It might also be very simple things like a running shoe, and yet that will generate lots of information based on the world around it. The data collected is extremely valuable, but it's also too much to be pushed back every time. Imagine if I had to push back 10 gigabytes of data in a car for every mile back to the centralized cloud to get processed. It's not going to happen. So it's got to be done out at the edge. Inference. The data being collected is very unstructured. It's the first time that we're seeing such massive amounts of unstructured and highly variable data. So the inference is going to come by machine learning extracting relevance out of the data itself. Whether it's a stop sign, a person, a tree, your running cadence, it's all that relevance is going to be extracted through machine learning algorithms. This will give us powerful task-specific recognition that's going to require training and data to, again, keep that loop getting ever so tight. Action is the final element after we sense, infer. Now we have to go do something about it. Critical safety responsiveness of edge systems is going to require real-time data decisions. That is, the latency between the edge and the cloud, waiting for the response is going to be too slow. But I was around when the world entered the first wave of distributed computing, and it was exactly the same argument. If I had a workstation on my desk and I could do processing at the edge, I don't have to wait for information to go back to the centralized. In those days, it was a server. The data accumulates at the edge and the processing stays near the data. And as IoT devices get more sophisticated and intelligent, the sensors and the computing is going to increase. So we're just seeing the beginning of it right now. Literally, in the future, there will be sensors in everything. There will be machine learning algorithms. And this stuff is going to get ever more complex in terms of the amount of data that's being collected. In the cloud itself, the cloud becomes a training center for all of this information. One of the fundamental sort of aspects of machine learning is that machine learning needs lots of data in order to learn. And so this new edge cloud model that I'm describing here has the beauty of lots of data coming into a centralized repository for getting smarter on that information. And so what will happen is we may have hundreds of thousands of automobiles out there collecting information. That information will be curated at the edge, so not all of it comes back. Important information from billions of devices coming back to a centralized cloud where learning occurs. The cloud is going to store important information, and then the learning is going to be propagated back out to all the edge devices. And that's how things are going to get smarter. So the cloud does have a purpose. It doesn't completely go away. And by the way, like SaaS applications and all that stuff will continue to work in the cloud, but this new model will really take it to a whole new level. Okay, so here are some predictions, kind of what happens from this point forward. One, sensor data explosion will kill the cloud. Sensors are going to produce massive amounts of data. The existing infrastructure will not be able to handle the data volumes or the rates, and data is going to be stuck at the edge, and computing is going to move along with that data at the edge. We are absolutely going to return to a peer-to-peer computing model where the edge devices connect together, creating a network of endpoint devices, not unlike we saw in the original sort of distributed computing model. This is going to have an impact on a whole variety of things, including network and security. If you think of the security challenges of all this data being collected and the networking challenges of connecting trillions of peer-to-peer devices, communicating with one another and probably processing information together without the knowledge of a centralized information pool is going to be one of the, I'll call it the opportunities or challenges of this next era of computing. The other thing is that we are going to move to a world of data-centric programming. It's kind of interesting in the same way that, I believe that cloud disaggregates into this new model. We're teaching everyone to code now. And we're teaching everyone to code logic. That is, if, then, else, and that's what everyone's learning how to code. Well, when you deal with data, we don't use if, then, and else. We're going to be using data to actually solve problems. And the next generation of coders will be more mathematicians and data analysts as opposed to if, then, elsers. And so there's a transformation of the type of talent that we're going to be needing in terms of this particular information. I also believe that there will be new programming languages developed specifically around the notion of data processing and data analytics that are very specific to these types of use cases. And finally, the processing power of the edge increases and the price will go down. We've seen this with every transformation of computing where we have these massive supply chains. So, if you think about the mobile supply chain, there's 5 billion mobile phones. That's a great supply chain. Actually, there's 20 billion that's been sold, 5 billion in use. So 20 billion of these devices over the course of time created a very interesting supply chain. It's why memory and CPUs and networking and all the stuff in a mobile phone is so inexpensive, because there's been 20 billion of them produced. Well, imagine when now there's trillions of these IoT devices. Think about the impact of the supply chain on helping to commoditize processing power and sensors. Just as some anecdotal evidence here, the current iPhone 7 has 3.3 billion, with a B, transistors. The original Pentium processor, right, in one of those big sheet metal cabinets in 1993, had 3.1 million, with an M, transistors. So think about the power increase between then and now. This is only going to accelerate that. From a cost standpoint, we're already seeing sensors. The whole magic here is sensors have to come down to a cost where I can put sensors in running shoes. So it can't be $100,000 sensors that go into running shoes. Otherwise, you're not going to buy a running shoe. LiDAR, which is used for detection in self-driving cars. You might have seen that on top of I don't know if anybody's seen pictures of the Google car. There's a LiDAR installation on top. The first LiDAR for a Google car was $75,000. Now LiDAR is sub $500. And I'll bet you, and this is just like, there are no self-driving cars out there. I bet you it goes to 50 cents in the not too distant future. Like, that's what happens. So power goes up by several orders of magnitude. Price comes down. What happens? I can put sensors in everything, literally. Every shoe, whatever you want them in. Glasses, in your ears, wherever. And all that then needs to be connected. The entire world becomes the domain of IT. So for those of you who think that your job as CIOs or IT managers have gotten easier, this is actually the opportunity of a lifetime. You move from 5 billion devices to 1 trillion devices that all need to be managed, that all need to be coordinated together. And every industry will be subject. It's not just like self-driving cars. If I'm in the insurance industry and I run a fleet of drones to inspect houses, who's going to manage that? Or I run an IT, a healthcare organization, and they do remote surgery using robots. And there will be so many applications that come about that combine what we think of as sort of consumer-oriented applications with enterprise manageability. And that's absolutely going to happen. So once again, as we saw with distributed computing in the late 80s and early 90s, and what we saw with cloud and we saw with mainframe, there's a big disruption on the horizon. It's going to impact networking. It'll impact storage, compute, programming languages, security, and of course, management. So for all of you, I would encourage you to get ready for one of the biggest transformations to occur on the computing landscape. It's happening right underneath our eyes. And what do you think now? Okay, thanks a lot.